Welcome back. This is where network security really starts to click. In Stage 6, Lesson 44, we're tackling access control lists, the standard, extended, and named varieties that form the foundation of traffic filtering on just about every network device you'll ever touch. By the end of this lesson, you'll understand not just the syntax, but the underlying logic that makes ACLs a universal tool across vendors. Here's the roadmap for the next few minutes. We'll start with ACL fundamentals, what they actually do and where they execute on a device. Then we'll demystify wildcard masks, which trip people up because they're the inverse of the subnet masks you already know. From there, we'll compare standard, extended, and named ACLs so you know exactly when to reach for each. And we'll close with placement strategy, because applying an ACL in the wrong spot can quietly undo all your careful filtering. Before we dive into syntax, let's widen the lens, because ACLs do far more than just block traffic. Yes, filtering source and destination IPs is the classic use case, like denying host 10.0.0.5 from reaching your finance subnet. But the same matching logic also controls which BGP routes get advertised, marks voice traffic with DSCP for QoS, and selects which flows hit your NAT pool. And whether you're writing Cisco IOS, Linux IP tables, or AWS security groups, the fundamentals never change. Top-down evaluation, first match wins, implicit deny at the end. Learn it once, apply it everywhere. Now, on Cisco gear specifically, you'll meet three flavors of ACLs. Standard ACLs use numbers 1 through 99, match only the source IP, and because they're so blunt, you place them close to the destination to avoid blocking legitimate traffic too early. Extended ACLs, numbered 100 to 199, give you the full 5-tuple, source, destination, protocol, and ports, so you put them near the source to drop unwanted traffic before it crosses the network. And named ACLs are the modern preference, descriptive labels like allow web, editable by sequence number with all the power of extended. Same rules underneath, just better ergonomics. Before you can write an ACL rule, you need to speak its dialect of math, and that means wildcard masks. They're the inverse of subnet masks, where a subnet mask uses ones for network bits. A wildcard flips it. 0 means match this bit exactly. 1 means ignore it. So A24, normally 256.255.55.0 becomes 0.0.0.255 in ACL land. Memorize a few common ones. 32 is 0.000 for a single host. 30 is 0.0.3 for point-to-point links. And 255.255.255.255 matches anything. And the rest becomes muscle memory. And when memory fails you, there's a simple formula to fall back on. Subtract the subnet mask from 255.255.25.2 octet by octet. So A24 mask of 255.255.255 gives you 0.255. Perfect for matching a whole subnet like 10.10.0. A single host has a mask of all ones, leaving a wildcard of all zeros, though most platforms let you just type the keyword host instead. And a 16, like 172, to help learn 6 expands to 0.0.255, covering every address in that range. Same formula every time. With wildcards under your belt, let's see how this all comes together on real Cisco gear. A standard ACL numbered 1 to 99 filters only on source IP, quick but blunt. An extended ACL numbered 100 to 199 gives you the full 5-tuple, protocol, source, destination, and ports, so you can permit web traffic to port 80 and 443, then deny everything else. And named ACLs are the modern way, readable, editable line by line, and far easier to maintain, but none of it matters until you apply it to an interface with a direction. And that direction, in or out, is where most mistakes happen. Direction is half the battle. Placement is the other half. The classic rule, extended ACLs go near the source because they can match destination and port precisely, so you drop unwanted traffic as early as possible and save bandwidth across the path. Standard ACLs, on the other hand, only see source IP, Place them too close to the source and you'll block that host from reaching legitimate destinations too. So put them near the destination, where this destination only is exactly what you mean. Now, placement only matters once you've picked a direction, and the same ACL behaves very differently depending on which way you point it. Inbound filters traffic entering the interface. It's applied before the router even does a route lookup, so bad packets get dropped early and CPU stays low. That's why inbound is the default choice. Outbound filters traffic leaving the interface after the routing decision is already made. Use it when you specifically care about what a particular exit port should or shouldn't see. With direction and placement clear, let's see where ACLs actually earn their keep in the real world. You might quarantine a compromised workstation with a single deny line, lock a DMZ web server down to HTTPS only, or restrict router SSH access so just your jump host can connect. At the internet edge, denying private address ranges gives you instant anti-spoofing. And notice that last one, ACLs aren't only about filtering. Here, it just classifies voice traffic so QoS can prioritize it. Same syntax, completely different job. Now for the mistakes that bite everyone at least once. The implicit deny catches beginners constantly. You write one permit line, apply it, and suddenly everything else is blocked. Order matters too. Put specific denies before general permits, because first match wins. Use named ACLs so you can edit by sequence number instead of rebuilding from scratch. Double-check your direction at the interface, and remember, wildcard masks are the inverse of subnet masks. A /24 is 000-255, not 255, 255, 255, 0. Let's pull it all together. ACLs are the universal filter, IP, port, protocol, running on routers, switches, firewalls, and cloud security groups alike. Remember wildcard masks, invert the subnet. Standard filter source only while extended gives you the full 5-tuple and placement matters. Extended near the source, standard near the destination. And above all, top-down evaluation, first match wins, implicit deny at the end. Master those rules once, and you've mastered ACLs everywhere. Here's your cheat sheet. Keep it close. Standard ACLs use ranges 1 through 99 and 1300 through 1999, filtering on source IP alone, while extended ACLs live in 100 to 199 and 2000 to 2699 with full 5-tuple matching. For wildcard masks, remember the 3 you'll use constantly: 0.0255 for a /24, 0.0.0.0, or the host keyword for a single address, and 205.255, 255.255, or simply any to match everything. And placement, standard near the destination, extended near the source to drop traffic early. And that wraps up ACLs. Next up in Lesson 45, we shift gears into VPN fundamentals, site-to-site and remote access tunnels that carry your traffic safely across the public internet. You've built the filtering foundation. Now we'll add encryption on top. I'll see you in the next one.